Okay, so we're going to move on to a little bit of more complexity here. And we've got our guidelines for plotting rational functions. So it says find and plot the y-intercepts, find the zeros of the numerator, find the zeros of the denominator. So the first one is to find the y-intercepts. And to find the y-intercepts, you set x equal to 0 and then evaluate the function at x equals 0. So you'll end up with 0 over -3 times +3, which is 0. So that's our y-intercept is 0. Now, 2 says find the zeros of the numerator, which will find you, so you look at the capital N of x, which is the numerator polynomial, which is x, and you find out the values of x where that equals 0. So you just set it equal to 0. We're not factoring anything because it's just x by itself. So the x-intercept, we have 1, which is at x equals 0. All these previous problems that we didn't have an x-intercept because there was no case where the numerator equaled 0 because it was just a constant. So that's setting the numerator equal to 0. The denominator for this polynomial is already factored, and so these give us the x locations of the vertical asymptotes. So you set this equal to 0 and that equals 0 when x minus 3 equals 0 or x plus 3 equals 0. So x minus 3 equals 0 when x equals 3, and x plus 3 equals 0 when x equals -3. So those are my y-intercepts. Find and sketch the horizontal asymptotes. Number 4, so do the horizontal asymptotes. We have these rules, and the rules say that if the order of the numerator is less than the order of the denominator, then the function goes to 0, which is the case here. And you might say, well, what does that mean? Well, if you multiply out the denominator, you'll get this, x squared minus 9. And because the highest order term in the numerator is x to the first, and the highest order term in the denominator is x squared, because 2 is greater than 1, if we take the value of the function as x becomes very large, then the denominator is something large squared divided, so you take something large divided by something large squared, and as x gets bigger and bigger, this ratio becomes smaller and approaches 0. So the equation for the horizontal asymptote is a y equals something. In this case, it's y equals 0. And it says plot at least one point between and one point beyond each x-intercept and vertical asymptote. So this you just pick some values of x that make sense to give you one more point to draw. So let's draw these numbers, and then draw what we have so far, and then we'll see if we can figure out what the I was looking for was the piece of graph paper, but I have to go find that. Okay, so insert a slide. Stick that over there, stretch it out. Nope. Okay, let's make this bigger. Okay, so we're going to plot everything we have so far. So the x and y, the y-intercept is 0 and the x-intercept is 0. So that crosses both the x and y axis here at the origin. So that's what we get from these two. The denominator set equal to 0, 0 gives us the vertical asymptotes, and those occur at x equals -3 and x equals +3. So those are the lines. And then we have a horizontal asymptote of 0. So what I do is after the asymptotes, the vertical asymptotes, I draw these horizontal lines because they really don't have any significance between these. Okay, so the question is, what points do we pick? And let's look at the description here. Plot at least one point between and one point beyond each x-intercept and vertical asymptote. So this is a vertical asymptote. We don't have any x-intercepts here, so we just pick some value of x. So we could put a point here, and we can pick one value of x here to pick a point. And then here we have an x-intercept and a vertical asymptote, so we might pick positive 2 and negative 2 and evaluate the function at those points. So that's what we'll do. So what we're going to do is we're going to do f of, let's pick 3, 6. So f of 6, f of negative 6, which is going to be the same, symmetric, f of positive 2, and f of negative 2. And there we just have to plug into the equation, which was x over x minus 3, x plus 3. So that's going to be 6 divided by 6 minus 3, 6 plus 3. And I get my calculator out of my bag. Okay, so it's going to be 6 divided by 3 divided by 9. 6 minus 3 is 3. 6 plus 3 is 9. We get a small number, 0.222. And if you plug in negative 6, what you'd end up with is you'd have negative 6 minus 3, negative 6 plus 3. So let's do that. Negative 6 divided by negative 9 divided by negative 3. And you get negative 0.222. F of 2 would be 2 divided by 2 minus 3 over 2 plus 3. And here we'd have negative 2 divided by negative 2 minus 3 and negative 2 plus 3. And they're going to have the same magnitude, just like in the previous example. This one's going to be positive, that'll be negative, that'll be positive. So this answer should be negative. And this one will be negative, negative, positive. So we have two negatives, so this should be a positive number. So we get 2 divided by negative 1 divided by 5, negative 0.4, and this is going to be positive 0.4. So go out to 6.222, that's about a quarter. Down over here, negative 3, negative 6, negative 0.222. And here we have a 2, we have negative 0.4. And over here, negative 2, we have positive 0.4. So now, one more thing we know is that, this is going to approach x from the positive side. This is going to go up like this. Again, it's hard to draw. Always the hardest time with these kind of graphs. Okay, and then because this is below the x-axis, from across the x-axis here, this is going to go down like that. This is going to go down here that, crossover, and then this one's at in this kind of quadrant, if you want to call it that. So there we go. Now, in retrospect, these points are very close to the x-axis, so I might have probably should have chosen maybe 4 and -4 to get a number that's a little bit further away from the x-axis. And here maybe pick something that's closer to -3, close to +3. So let's look at the actual graph of this thing. So there you go. So you can see, and the units, this is 1 unit. So this is 0.4 right there, and this is -0.4. And then at +6, we're 0.22, and here we're at -0.22. So this one looks slightly different because the scale in the x direction and the y direction is a little bit more spread out. Now let's look at the same problem, except we've got a negative sign. So really all that's going to do is we're going to have the same x, y intercepts, the same horizontal vertical asymptotes. The negative sign, that means everything that was negative becomes positive, and everything that positive becomes negative. So I'm just going to draw it in here. So instead of the function looking like this, it would essentially be a mirror image of the function. So it would go that way, and then it would come down this way from the top now, through there, go through the x-axis, down all the way to here, and then we cross over and come here. So that negative sign in the numerator just acts as a reflection across the x-axis. Okay, so here's a little more complicated one. And again, this, if we multiplied this out, we'd have x squared minus 1 over x squared minus 9. So we might be given the problem initially in that form, and then we factor it and find out that this has 2 roots and this has 2 roots. Okay, so what I was going to do is go through the list of the things that we need. First thing is the y-intercept. And to get the y-intercept, you set x equal to 0. So it's actually easier to do it in this form. So if you set x equal to 0, f of 0, these two terms drop out, the negatives cancel out, you get positive, you just get 1/9. Okay, so that's the y-intercept. To find the x-intercepts, you set y equal to 0. And to get y equal to 0, the numerator has to be equal to 0. So we set the polynomial that represents the numerator equal to 0, and in this case, we can use the factored form. So we set that equal to 0, so that happens when x minus 1 equals 0, or x plus 1 equals 0. So this becomes x equals 1 is 1, 0, or 1 x-intercept, and x equals -1. So we have 2 x-intercepts. To find the vertical asymptotes, you set the, that should be n, the numerator, not the denominator. Okay, so here we set the denominator equal to 0. And again, we can go ahead and use the factored form. So to have the denominator equal to 0, that's where the function does not exist. It's when x minus 3 equals 0, or where x plus 3 equals 0. So we set the factors equal to 0, and that gives us the zeros of the x-intercepts. And then the horizontal asymptote in this case, you can see when I multiplied it out, it's easier to look for the horizontal asymptote. It's not negative 1, it's not 1/9. That's to find the y-intercept. So, if you want to find the y-intercept, it's this form. The multiplied out form is better. If you want to find the horizontal asymptote, the multiplied form out is better. To find the x-intercepts and the vertical asymptote, the factored form is easier. So what we look for in the horizontal asymptote is we look for the ratio of the highest order terms. So we've got x squared is the highest order term here, x squared is the highest order term here. So because these are the same, the rule says that we use the ratio of leading coefficients. Well, the leading coefficients are 1, which are not shown explicitly there. It's only when the number is different than 1 that we show it. So the equation for the y equation for the horizontal asymptote is just the ratio of the leading coefficients, which is 1. So we have a horizontal asymptote at y equals 1. So now here's what it looks like, but let's plot it first. And let's use the expanded version of the scale. So instead of from 0 to 10, we'll go 0 to 5, and then go -5 and 5 and 5. So that means we have each 2 tick marks is a single value. Do that in all directions. Okay, so plot the y-intercept. That's y equals 1/9. So this is, and let me go ahead and put some numbers in here. 1, 2, 3, 4, -1, -2, -3, 4, 1, 2, 4, -1, -2, 3, -4. Okay. So the y-intercept is positive 1/9. This is a half. 1/9 is going to be probably about right there. The x-intercepts are -1 and +1. The vertical asymptotes are ±3. So we draw vertical lines there. Okay, now we can draw a pretty good curve without evaluating the function at some more points. But let's follow the rules. So you can, we could pick x equals 4. Here's an x-intercept and a vertical asymptote, so we could pick x equals 2, x equals -2, and x equals -4. So let's do that. So we're going to do f. Let's just start from the most negative number. And again, because of symmetry, these are going to have the same magnitudes. So we have, it's probably easier just to use this form. I mean, we can use either form, but let's use x squared minus 1 over x squared minus 9. So that's going to be -4 squared minus 1 over -4 squared minus 9. This will be -2 squared minus 1 over -2 squared minus 9. This will be 2 squared minus 1 over 2 squared minus 9. This will be 4 squared minus 1 over 4 squared minus 9. And one thing you'd notice is these are squared. So these are going to be pumped positive, and these are squared as well. So because these are even exponents, these values are going to be the same as these, and these are going to be the same as those. So we can do one of them and then just apply it. So the first one will have 16 minus 1 divided by 16 minus 9. So we get 2.14, so this is going to be 2.14 as well. And the next one we have 2 squared minus 1 divided by 2 squared minus 9. So that's a negative 0.6. This is negative 0.6. So let's plot those points. I'll use green. So here we have 2, and you can see that it has to be negative because here it goes up above the x-axis. It's going to come down. So 0.6 is 0.5, so 0.6 is right here. Likewise over here, negative 0.6. Out here we have 4, 2.14, so here's 2. It's 2.5, 2.1 is something right here. Likewise, right over here, negative 4. It's 2 point something right there. So this will come from the negative side. Go up here. Go through the x-axis, through the y-intercept down here. Symmetry comes down like that. And of course, this, because we have a single root at x equals 3, we're going to go from negative to positive. And then it comes like that, and then it's going to go something like that. And likewise, this thing's going to be symmetric. So there you go. And there you can see, notice how this doesn't approach the x-axis quite as quickly. And that was reflected in this point. We may have, without that extra point, we may have tried to do this a little bit too sharp. Okay, so now we got, we're adding one additional term here, which gives us another vertical asymptote. So let's find the y-intercept. You do that by setting x equal to 0. And in this case, if you set x equal to 0, the function does not exist. So it turns out there is no y-intercept because f of 0 is, these are all non-zero. And this is 0, so you get non-zero divided by 0. Just does not exist. 2 is find the x-intercepts. So you set y equal to 0. So for the same reason we get x equals -1, x equals +1. So those are my x and y-intercepts, my vertical asymptotes. That's where the denominator equals 0. So what we do is we pick up this additional vertical asymptote at x equals 0. And we still have the same 2 remaining. And because of this additional x in the denominator, if we multiply this out, we'll get x squared minus 1 over x cubed minus 9x. How did I do that? Well, these are the same except there's an additional x. So when we multiply these two together, we get x squared minus 9. So if you multiply both those terms, x squared minus 9 times x, you get x cubed minus 9x. So the answer is y equals 0 is the equation for the horizontal asymptote. Okay, so let's get a piece of graph paper. And again, we will plot these things on here. let's use the same scale we used on the last one. So this is 5. This is 5. -5. Okay, so let's continue on here with marking up our graph. So, okay, so this goes to -5. 1, 2, 3, 4. -1, -2, -3, -4. And you might say, why is he putting them on one side sometime and the other side? And the answer is, I don't know. So what we're doing is we're just going to kind of get a general idea of what's going on here. So we have the differences. In this case, we did not have any y-intercepts because when we plugged in x equals 0, we ended up dividing by 0. And we have 2 x-intercepts, so same as before. And we have 3 vertical asymptotes instead of 2 vertical asymptotes. So we have one at 0, which we did not before. We have one at 3. We have one at -3. So what you can imagine here is that you're probably going to either go this way through this point up like that, and then flip over because we got one single root here, so it's going to go from positive infinity to negative infinity. And then we'll come up like that. And actually, now that I think about it, it goes the other way, because when we have all positive, big positive x numbers, we're going to have a very small positive number. So we'd end up coming from the positive side of 0. So we'd go up like that, come down here, go like that, go like that, and then come up and then reach that. So we've got, we need to draw our horizontal asymptotes, which are 0. So here's the horizontal asymptote here outside of the furthest vertical asymptote. So if we want to follow the rule that we need to have one point between the intercepts and the vertical asymptotes, we're going to need quite a few points. Probably pick -4, -2, +2, +4. And again, because of symmetry, the values are probably going to be equal to each other as far as the magnitude. The signs may be different. Don't know yet. Okay, so let's insert a page here. And so what we said is we wanted to pick -4, -2, +2, +4. Maybe, I guess we could pick a half, +1/2, and -1/2 as well. So that actually gives us 6 points that we evaluate the function. This we know the basic shape of this thing. So let me explain that, and then we'll do these intermediate points. So as I said, we start at the positive side of the horizontal asymptote. So we're going to come up here. We're going to go up here because if we went down, we'd have an x-intercept, which we don't. So it has to stay on this side of the x-axis. And because we have a single root at -3, we're going to flip from positive infinity to negative infinity, which means we're going to come up here, through there, and do that. And you're going to have the same behavior here. So it's going to go from positive infinity to negative infinity, go through here, and then positive infinity down negative infinity, and we're going to stay in the negative area. So what we're looking for is we're looking for a point here, a point there, maybe a point here, a point there, maybe, and a point down here, and a point right there. So those are the values of x. So we don't know exactly where those sit. So what we'll do is I'm going to just undo all those things. That's the general shape of the curve. So once we get these extra points in, we'll be able to draw a better representation of this thing. Okay, so there we go. And remember what we had, we use a multiplied out version just because that's going to be easier to evaluate. Okay, so put negative 4 squared minus 1 over negative 4 cubed minus 9 times negative 4. So negative 4 squared is 16 minus 1. Divide that by negative 4 cubed, which is going to be negative 64. And negative 9 times negative 4 is positive 36. So we get the numerator divided by negative 64 plus 36. And I needed to use my calculator correctly. So what I get is negative 0.54, which agrees with what I said that it had to be down here. Okay, now we do negative 2. Negative 2 squared minus 1 over negative 2 cubed minus 9 times negative 2. Okay, so negative 2 squared is 4. Subtract 1, we get 3. Divide by negative 2 cubed, which is negative 8. And add 18, negative 9 times negative 2. And I get 0.3. Okay, now we'll do the positive 2. 2 squared minus 1 over 2 cubed minus 9 times 2. So in the numerator I have 4 minus 1, which is 3. So I have 3 divided by 2 cubed, which is 8, minus 18. So that's negative 0.3. So again, symmetry, differences of the sign. Okay, next one is 4 squared minus 1 over 4 cubed minus 9 times 4. So that's 16 minus 1, which is 15, divided by 4 cubed, which is 64, minus 36. And I get positive 0.54. Here I got negative. Okay, the next one is 1/2 squared minus 1 over 1/2 cubed minus 9 times 1/2. So 1/2 squared is 0.25 minus 1. Okay, divide that by 0.5 cubed minus 9 times 0.5. And I get 0.171. And I bet I'll get negative 0.171 here. So negative 1/2 cubed minus 1 divided by negative 1/2 cubed minus 9 times negative 1/2. Okay, so negative, actually maybe you're not going to get the same number. So if I take negative 1/2 squared, so yeah. So that's why I was thinking make it a different number, but that should be squared. Okay, so negative 1/2 squared minus 1 is negative 0.75 divided by negative 1/2 cubed minus 9 times negative 1/2, and I get negative 0.171. Okay, so now we can plot all these points. So negative 4, negative 0.54, so that's about right there. Negative 2, positive 0.3, which is going to be about right there. Positive 2, negative 0.3, which is going to be about right there. 4, positive 0.54, so that's there. 1/2, right there. Well, negative 1/2, negative 0.17 is going to be about right there. And positive 1/2, I get a positive 0.171. Okay. So now I can draw my picture. So we come over here, we're approaching the x-axis from the negative side, go through this point, then go around, go to this asymptote, go up to this side, come on down, something like that, through there, down there, all the way to negative infinity, then come up here, come down, through that point, through the x-intercept, through that point, down, all the way down to here, flip over to the top, come down here, through there, da da da. Okay, so that's it. So let's look at the actual plot. And you can see, looks exactly like it should. So here's negative 4, negative 0.54, here's plus 0.54, here's negative point something or other right there. Okay, so you can see match up pretty darn close. Even our initial picture was pretty good. We probably would have had this maybe steeper. Okay, so that was that one. Oh, this is moving into the numerator. So this video's getting a little long, so we're going to stop and we'll have part 3.